Welcome to the Holistic Psychiatry Podcast. I'm Courtney Brown Snyder, a physician and holistic adult and child psychiatrist. In this episode, I'm delighted to be sharing a conversation I had recently with Dr. William Walsh about his discoveries into the cause of bipolar disorder and his book on this very topic called The Essence of Bipolar Disorder. For those who aren't familiar, Dr. Walsh is the founder and president of the nonprofit Walsh Research Institute and is internationally recognized as an expert in the field of nutritional medicine and psychiatry. Dr. Walsh started his professional path as a nuclear scientist at the Institute of Atomic Research at Los Alamos before obtaining his PhD in chemical engineering. While working at Argonne National Lab in the 70s, Dr. Walsh organized a prison volunteer program that led to studies of prisoners and ex-offenders researching the causes of their violent behavior. The collaboration with renowned and late Carl Pfeiffer, MD, PhD, and a pioneer in the field of nutritional research therapy, led Dr. Walsh to the development of individualized nutrient protocols to normalize body chemistry and brain chemistry in those with disorders such as depression, anxiety, bipolar disorder, schizophrenia, Alzheimer's, and autism. Dr. Walsh went on to study more than 30,000 patients with mental disorders, acquiring an unparalleled database of more than 3 million chemical assays. Included in that are chemical assays of 3,600 people with depression, 6,500 with autism. It even includes 25 serial killers and mass murderers. Dr. Walsh has assisted the FBI and Scotland Yard and has designed nutrient protocols for Olympic professional athletes. Among his discoveries were that 70% of individuals with psychiatric conditions have a methylation imbalance relative to 30% of the general population. He found that 90% of those with mental health conditions have low normal or deficient zinc levels. He found biochemical phenotypes for depression, including undermethylation, overmethylation, pyrrole disorder, copper toxicity, and metal toxicity. Similarly, he found the biotypes of schizophrenia and ADHD. He also found that overwhelmingly, women with postpartum depression or anxiety or psychosis have high copper levels. His most recent discoveries relate to the ever-elusive bipolar disorder. After 8 years of studying recent advances in neuroscience, genetics, and epigenetics, Dr. Walsh reveals answers to many of the core unknowns about bipolar disorder that have confounded psychiatry for more than a century. Affecting more than 70 million people worldwide, this condition remains among the most disabling and deadly of all mental illnesses, a leading cause of suicide, unemployment, and lost human potential. In his new book, The Essence of Bipolar Disorder, Dr. Walsh presents a rigorous, evidence-based theory reframing bipolar disorder as a late-onset epigenetic illness driven by specific genetic vulnerabilities, progressive DNA damage, and ion channel dysfunction. And by ion channel dysfunction, that relates to these channels that are on neurons that allow for the movement of potassium, for example, in and out of the cell, which allows for an electric current to move down a nerve cell. I first met Dr. Walsh in the fall of 2014 at his second physician training course here in the U.S. Since that time, I have repeated the training course and gone on to serve as faculty in one of the Walsh training conferences. I also had the pleasure in 2016 of sitting down with Dr. Walsh over lunch and interviewing him on his journey and his pioneering work. That is included in a blog post that I will link to below, titled Lunch with Dr. William Walsh, His Story, Discoveries, and the Future of Nutrient-Based Psychiatry. I feel like we're already into that future, and we still have much more to look forward to in terms of his ongoing work and research. So without further delay, here's my conversation with Dr. William Walsh.
Well, good morning.
Hi there.
How are you?
Good to see you.
I've been
Congratulations.
doing a lot of interviews and I read what you just sent us, and you have a clearer understanding of this than anybody I've talked to so far.
Thank you.
Have you seen the book?
I saw it on the web. I haven't physically held it, but I've seen it on the
You,
Walsh Research Institute website.
you're going to find it very, very interesting, especially
Yeah.
the chapter 8 where I discover the cause of bipolar disorder.
Yeah, and I'm hoping as we talk that you could sort of talk about that sort of the story of your discovery as we talk about the science. So that, because I think
Oh,
that's so interesting. Why don't we start with talking about the bipolar disorder that we're talking about and sort of what we're not talking about? Because I think my audience has a sort of a broad understanding of the different types of bipolar disorder.
basically, in the first chapter of the book, um, I mentioned the different names that are given to this disorder. And what I've decided to do arbitrarily is focus on bipolar 1, bipolar 2, and cyclothymia. And
Mhm.
then I discussed that there is rapid cycle bipolar. And the reason I want to not do these other forms or other titles or names given to the disease is that, for example, rapid cycle, and there's other names for it, but it seems to me it's so similar to severe pyrrole disorder
Yes.
that I think it might be concomitant. It might not be true bipolar. It might be something that resembles bipolar. It has gotten that name. So, but that's the real reason. But that's why I'm focused on those three.
Relative to other psychiatric conditions, bipolar disorder is really unique and has kind of been an anomaly in terms of understanding this high and low neurotransmitter functioning. So,
Exactly. Yeah, and the basically when I first got involved with this, I was deciding actually a lunch meeting with my best friend who was a psychiatrist who was in charge of a medical school, the number one medical school in Chicago for psychiatrists, and we were talking about just mental health in general, and we were talking about bipolar. And we were both really frustrated that no one really knows what it is. And after a century of research and studying, um, still no one knew the cause. And the mysterious switching between mania and depression, um, there have been a few theories of it, but really it's still unknown. And it's really difficult to fight an enemy if you don't know who or what it is. And compared to other disorders, bipolar disorder has been a mystery, primarily a mystery. And and I believe that is really the number of things that's held back the ability to develop effective therapies. I think we just simply don't know quite what it is. And the mainstream medicine bases everything on the diagnosis primarily, and then they have evidence that certain medications have efficacy. And however, it would be so much nicer if we were able to identify what neurotransmitters are misbehaving. And
right.
we know a lot about bipolar. We know what, but we don't know why. And I think that's been a real barrier to progress. So I decided at that meeting I was going to spend, we agreed, I was going to spend 6 months studying recent advances in neuroscience, and there's been a lot of
Hmm.
remarkable studies going on. There's 250,000 neuroscientists in the world. There are about 1,000 new studies every month. And some of these studies are really quite brilliant and wonderful. Others are not particularly important, but it's really difficult to. The hope was that I could spend 6 months studying all of this and maybe finding some insights to what bipolar really is. So that's how I started. And as I got going, I found that there was dramatic improvements and advances in neuroscience, but especially in genetics. That was the part that I thought that I found surprising is the dramatic improvement in the understanding of genetics and the possible genetic predisposition. So my
And so
six
this
months
would,
turned into more than 6 years. In fact, closer to 10. And it's been
oh,
really
wow.
exciting, and I've really enjoyed learning all of this. For a long time, people thought that bipolar, first of all, there was the mania itself, the mania that, which is usually the beginning at the onset of the condition,
Right.
and it's known that most of the major neurotransmitters are hyperactive. That's quite well known, especially dopamine and norepinephrine. Um, and and but then the question, the mystery has always been, why
The
is there
switch.
the switch? What
Hmm.
is the cause of this mania that tends to worsen with time? I've seen 1,500 cases of bipolar, and I've got the lab results, and we've studied them. And usually it can start for some people so suddenly and mysteriously, usually after the age of 20. Median age of onset is 25, and they suddenly have all this mania or hypomania, depending on what version of bipolar. But it gets worse and worse in most cases, especially for bipolar one, and often leads to psychosis. Um, but then what could possibly cause it to suddenly switch into a totally different condition that is dominated by severe depression? And that's been a mystery. It's been called the holy grail of bipolar for researchers, is try to understand and get the mechanisms in the explanation for the switch. And
Right.
I believe that my investigation has discovered that also. And I had an unfair advantage looking for that compared to other researchers, because I first discovered that the primary cause genetically had to do with malfunctioning, the malfunctioning team of ion channel genes. And these ion channel genes that are embedded in their neuron membranes are what really orchestrate neurotransmission.
So
They're
the communication down a cell that starts
Yes,
with
it's the reason
neurotransmitter.
we have the unstable neurons. They cause the instability. They cause the
Hmm.
predominance of potassium within the neuron and sodium ions outside the neuron, and we get the voltage or the potential. And
Right.
without it's the ion channels that cause action potentials, the neuron firing events. And so once we learn that, instead of looking at the 100 or 50 or 100 different possibilities for the cause of switching from mania to depression, I was able to focus totally on ion channel factors. And that's how it took about 8 months, but I think we found exactly what it is.
So you started with looking at the research in terms of what the genes were that were showing up, and
Well,
then noticing that a lot of those related to the ch ion channels? Is that,
I did not get involved with the genes until about the third or fourth year.
oh
Uh,
my,
I was
okay.
focusing mainly originally on neuroscience and learning a lot about how the brain works and factors that could cause hyperactivity or lower activity, and looking at all of that. And so it wasn't until really about the fourth year of this investigation that I began to realize that these dramatic improvements and advances in genetics, where we were actually able to, for the first time ever recently, to identify some genes that were actually related to it. The big
Oh, that's great.
surprise with genetics is,
That went
first of all,
backwards then. Okay.
it's backwards. The real surprise in the beginning is, why are there no prominent bipolar genes? For 30 years, with very careful, beautifully done work, we could not find, no one could find a single gene that was related to bipolar, despite the
Were
fact,
there were there
despite the fact,
multiple? Oh, go ahead.
despite the
Sorry.
fact that it is the most heritable of all conditions.
Right,
Is
right,
by
right.
far the strongest. If you look at twin studies, if a mother and father both happen to have bipolar, the likelihood that a child will have bipolar is 75%. You compare that with
Wow.
schizophrenia
Mhm.
or or with major depression or any other condition, that's down, it's like 3 or 4 or 5 times more. So it's extraordinarily powerful genetic predisposition, but not a single gene could be found.
So were
And
there
what they
multiple
discovered,
genes? I mean, was that with the gene-wide study, I guess 2021, were they finding multiple genes
well,
that
that
seemed to
was
be
the
associated?
dramatic improvement. It started in year 2000.
Okay.
And realizing that it was such a heritable condition, but not any major gene, that led to the conclusion, and it's correct, that the bipolar is related to a multitude of low effect genes, small effect genes. And not no, now I know it's the team of 400 collaborating ion channel genes that
Wow.
enable the
Mhm.
brain to work. And what happens is you get a genetic weakness in that team. I learned that genetics had been focusing almost totally on individual genes. Only very recently they're starting to look at collaborating genes. See, some genes only have a single job, like the SERT gene enables reuptake.
Right.
But many of them collaborate to enable complex functions, like cardiovascular function or immunity or brain function. They're collaborating genes. And so what happens in the case of bipolar is that there are these 400 plus ion channel genes that are dominating they enough of them are mutated of these small effect genes that it can cause the regulation of brain function and regulation of normal steady activity. It's really quite remarkable how a neuron can fire and within a few milliseconds be ready to fire again. It's just amazing how that works. It's just so strongly regulated. So
And is
what
it like with 400 potential genes, like about how many might need to be have a mutation for there to be
exactly? And which ones? What, how about all the combinations?
oh, right, right, right. And some carry
Right?
more weight than others. And
Yeah, it might take 30 or 40 or 50 of them to be malfunctioning, but what version? And I think that has a lot to do with the different types of bipolar that we see. I believe that a psychiatrist that sees bipolar patients, that they probably will never ever see two people with the same disorder. There's so
oh,
many
wow.
different
So interesting.
multitude of combinations of these misbehaving genes. And that explains a number of things. It explains, for one thing, why they couldn't find a single gene that was dominant. And it also explains the heterogeneity that psychiatrists find. In other words, the great variety of symptoms and traits across bipolar. They're all so
Right.
different.
And even age of onset.
Why does it why don't children get this disorder?
Mhm.
Why is it usually in late adolescence um, that you get onset of the condition and the median age again is 25, age 25. Well,
Mhm.
what's going on in those 25 years? And there's been a lot of theories for that. Psychiatry would believe for many years it had to do with leaving the family, that it was the trauma
Huh.
and difficulties
Yeah.
associated with that. Then for about 10 years, the big theory was, no, it has to do with puberty. The changes in puberty can change your biochemistry, your brain chemistry. And then maybe 20 years ago was an even better theory, and that was that we now knowing that after puberty, the brain begins to prune neurons. And there's quite a lot of brain pruning,
Right.
and the most, I think the most recent theory has been that the brain pruning that goes on during teen years might have gone wrong. Very logical, plausible, but I think now I've discovered the real reason.
And
And
that last theory would be somewhat consistent with schizophrenia, would you say? the pruning
Yes,
theory.
I think they're both what I call DNA damage disorders,
Hmm.
where you
Hmm.
have a genetic predisposition and you have some malfunctioning mutated genes, usually in a maybe the brain, for example, maybe there's 1,200 genes that collaborate to have your brain function really well, but it's with special, and there are things that can go wrong. But in the case of bipolar, what's going wrong is that you have a genetic weakness in the team of ion channels. And so that and however, it takes relentless DNA damage and accumulation of new mutations year by year by year until you get to the point where you've lost control of neuron regulation. And in general, you tend to get hyperactivity and
And do
across
you,
many neurotransmitters.
and when you say mutation, do you mean the person already has sort of like like a vulnerability, but then epigenetically it gets expressed? When you're saying mutation, I just want to make sure I understand.
There's two kinds of mutations. There are
Okay.
somatic mutations, which are inborn,
Right.
and then there are new mutations that develop with time, with DNA damage.
Okay. So that's what you're referring to.
That's what I'm referring to.
So the vulnerability is there, and then there's some damaging oxidative stress that's
Well, you get additional damage, and so what you're getting is more complexity and more damage. You're accentuating and magnifying those those genetic imbalances, and it gets worse, more complex, and more severe with time, and it eventually gets to the point where you lose effective regulation of some of the really important neurotransmitters, initially with hyperactivity, which
right.
is and we know that mania is associated with hyperactivity of norepinephrine, dopamine, and a few other neurotransmitters. We know
So
that.
let me ask you because I know we'll talk about that what's happening when someone's going from euthymia to mania to depression and then euthymia. But before that, can you comment on I understand there were the genes that related to the neuron channels, but were there also genes related to protecting the DNA that were also implicated?
Well, that was
Um,
exactly the what led to everything else. The answer is absolutely yes. And that's how
okay.
we were able to discover what the cause of bipolar was. And it was the fact that there are 264 genes, and they're finding a few new ones that have to do with DNA repair.
Okay.
Our DNA is ripped apart viciously every day from the day we were born. And we have this remarkable, rather astonishing ability to repair that quickly. And three people just got a Nobel Prize in 2015 because they explained exactly detailed how that works. But the point is that it's not 100% perfect. And so what happens, and the reason we age, the only reason we age
Hmm.
is failure to protect our DNA, that we're getting DNA damage, usually quite small and incremental in the beginning. But that's why we age. It's also the primary cause, I'm sure, of late onset diseases, including cancer, heart disease, and mental illnesses. The late onset comes because we're getting additional mutations formed year by year. And the disease you wind up with, which might be kidney disease or something else, depends on what your weaknesses were when you were born.
Hmm.
Um, we are all born with some of our systems working beautifully. We talk about people who might live to 110, and they'd say, well, they got good genes. They probably have great DNA repair genes. They probably have great genetic protection against oxidative assault. Um, well, now we so actually the genetic the what you just asked me is the key to everything. The when we came to realize that we were able to eventually, starting in 2006, that was when they first found the first bipolar gene.
Hmm.
And they got this with a p-value of 10 to the minus 9, and it was absolutely definite. But since then, year by year, they're finding more and more of these small genes. And it got really exciting in 2018 when there were 32 of them, 31 genes with 32 variants. One of the genes had two variants. And so myself and hundreds of others, even though we knew this might be only a tiny percentage of the ion channel genes that are possibly mutated, maybe only, 32 out of maybe 1,200, still, uh, so many of us just dove into that and wondered, well, what genes are they? What are they related to? So
Hmm.
everybody's been studying these genes. And I think that I might be the only one I know of that realized that some of the genetic predisposition had to do with damage, with weakened
Hmm.
DNA damage genes. There's at least 260 of them, and they're the ones that repair the damage. And then we have 63 known genes that specifically protect and regulate oxidative stress, so we
Right.
don't get oxidative overload. And those are also weakened, some people.
Hmm.
So what I did was different, is I did an exclusion analysis. And I identified the genes that were primarily damage genes. And the big surprise, when I looked at the first 32 of them, most of them are cancer genes.
Hmm. Hmm.
At least two-thirds of all the predisposing bipolar genes are cancer genes.
Right.
So what does that mean? It means that these are genes that are affecting the entire body, and they're obscuring the ability to find the true bipolar genes. So what I did is an exclusion analysis, where I very carefully identified gene by gene which ones were related to DNA damage, like
Hmm.
major cancer genes,
Right.
genes that were associated with fatty acid deterioration, and to my surprise, out of the 32, there were only 10 that looked like they actually had to do with bipolar disorder. And the
Okay.
others, and the others were
Mhm.
obscuring it all because they all were related to DNA damage. And so what I found was that if you look at them one by one, almost all of them are directly related to ion channels, including some of the major ion channels that enable neurotransmission. And
So is
then
it
if
both
you,
then? Is it
so
both a vulnerability to damage and then also these particular ions? It's a combination of both those genetic vulnerabilities
Well,
together.
yes, exactly. It's exactly what it is. It's a, and
Okay.
it took me a few months I was focusing at the beginning on, wow, I've discovered ion channels look like that is the cause,
Hmm.
even though we need to, get more and more information. And after a while, I realized, wait a second, if nearly 75% of the predisposing genes are DNA damage, could it be that DNA damage, accelerated DNA damage? Maybe that's a prerequisite. Maybe that is something that is necessary, and maybe it's these two factors together. And so, yeah, in my book in chapter 8, I've done the analysis, and then 5 years later, they found another 32 genes. So now we got 64 genes. Again,
Hmm.
there might be 1,000 or more. And so I went through the same analysis again, and I
Hmm.
found there only five more that seemed to be true bipolar genes. So now I've got 15 of them. And yes, all of them, not exactly all, but uh, clearly it's primarily the big, strong, powerful ion channel genes that regulate neurotransmission, that have to do with getting rest potentials, that have to do with the whole sequence of recovery after a neuron fires. Um, so it became, and then I said to myself, now wait a second, if this is true, if a human being has weakness in DNA repair and weakness in protecting against oxidative assault by free radicals, um, then these people, they should be sick all the time because every part of
Right.
their body is being attacked. So then I thought, well, they probably would die younger. And so I looked and I found that in the literature that is very well understood. And so what I found
Mhm.
out was that people that have bipolar, if you look at the whole population of the millions that have it, and they've studied, this has all been studied, they have more than twice the chance of dying of a heart attack. They have increased incidence of cancer. They have increased incidence of kidney disease. Immune function is terrible. So
Mhm.
across the board, they are, as a population, they have terribly poor health.
Right,
That's
right,
consistent with the fact that these people have a genetic impairment in the ability to protect their DNA
right.
and avoid these additional mutations that are occurring day by day, and they're aging faster. And so then I looked at the statistics on life expectancy. They died 12 years younger on the
Oh my.
population. The median age of death for bipolar is 67 years. For the rest of the population, it's 79 years. So not only do
Mhm.
these poor people have to deal with the great difficulty of dealing with mania and depression, they also have poor health and
Right.
early death. What a
So it's
terrible
almost,
position.
I mean, some of what you're describing would apply to just brain-related conditions in general, but this is even more so. I mean, people with brain-related symptoms have more oxidative stress, more illness, but this is even more specific, more amplified because
And,
of these
and
DNA repair
I,
genes.
I thought 5 years ago I had enough information to write a book on it. And I kept saying, well, my book will be out in about, and then I would learn something else and something else.
Yeah.
Well, in the last
Yeah.
year, just in the last 6 months, something I learned from cancer research, they've discovered that if you have ion channel impairments, it causes additional DNA damage.
So that's key,
So
right?
the ion channels itself means you have an additional cause of assault on your DNA and
Mhm.
additional more accelerated development of new malfunctioning genes or essentially mutated or the mutations or the ability to have the proper expressed genes. And it's
Is
important
that
to
be
realize that we have that our DNA not only tells what our color is and our height and our characteristics and personality, it also is a source of one of the major sources of nutrition. And our DNA orchestrates what I call a genetic restaurant in which every part of your body, every cell line in your body, every cell in your body has a menu of 80,000 proteins that are from your DNA. But every part of your body has to have, I mean, your DNA is all identical in every cell, but you have to get the right nutrients.
Mhm.
You have to, there are some that are necessary and ones you need to avoid. And that's all done by epigenetics during the 9 months of gestation. But that's part of it all. And we can't exist for a minute without these genetically choreographed genes. And so what happens is that the reason we age is that the quality of that nutrition from our 25 trillion DNA strands is deteriorating with time. That's why we age, and it's why different functions in our body gradually get worsened and worsened. And if you happen to be born with a problem with the ion channels, which the bipolar people
Mhm.
have, that's what's going to probably come up. Whereas if somebody happened to have a problem with, say, immunity, genetic weakness in immune function with that different collaborating genes, then those are the people who probably, with as they age, would develop that issue. So it's kind of
Okay,
an
I
interesting
understand.
looking at
Right. So
all
DNA
of this.
damage in combination with the vulnerability, in this case, the ion channel genes.
So in chapter 8 of my book, in headlines, I
Mhm.
say I conclude that the cause of bipolar disorder is mutated ion channel genes, weakness in the team of ion channel genes, together coincident with accelerated DNA damage. Okay,
So
so I think that's
so
what it is.
So those vulnerabilities in combination with sources of oxidative stress, I mean, sources of sort of the input, whether it's toxins, which we're all getting exposed to, trauma, I mean, anything that would increase oxidative stress on top of those genetic vulnerabilities.
You're absolutely right. So you've got the inborn tendency, and you've got the nasty tendency for not being able to handle oxidative stress. And then you might be in an environment that has high oxidative stress, or
Yeah.
maybe in a diet that doesn't have isn't proper, or maybe you have trauma or really terrible things happen. We now know that trauma itself can is more than just memories that are troubling, but it actually can change neurotransmission. It
Hmm.
can change the
Right.
function, that permanently change your brain to function quite properly. So there's
Right.
all of that. I've had so many patients that wondered, I wonder what I did wrong. I wonder if I made this mistake or that mistake, and maybe I brought this on myself. No. And then I've met a lot of families that wondered, maybe we didn't treat our son right, or maybe there was some trauma. No, it's like a lightning striking. And you either do or you don't have this ion channel malfunctioning at birth. But if you have that, it's probably going to happen, even in an ideal environment. It might
Hmm.
just be a
Right.
matter of whether how early it happens or how severe it is. But
Okay.
it's like lightning striking. It's no one's fault. It's really no one's fault. You might be able to cause enough oxidative assault on a human being that you could maybe have that happen, but I think it would probably turn out to be something other than bipolar. So they get this distinctive, unique, I call it a singular illness. It's unlike anything
Hmm.
else. And it's really interesting, equal number of males and females, and it occurs equally every part of the globe, whether they're
Right.
Eskimos or born in Africa or born in America, or it seems like the rate is the same incidence rate. And it's been a total mystery, but I think it really helps to understand it. Now, looking at all of this, the question is, what can you do about it? How can this information help doctors and help patients? And I think that I spent a lot of time looking at whether gene editing and CRISPR and things like that might be helpful, and the answer is
Hmm.
not likely at all for the next 30, 40 years. And the reason is that that works beautifully if you've got one or two or 10, just a few misbehaving genes. The gene editing could be quite wonderful. But the problem is you've got thousands, tens of thousands of combinations of genes. So, and the same, I think, is true of schizophrenia, by the way. Um, they're doing the same kind of analyses for schizophrenia. But so what can you do? But what you can do is I think you alluded to the progression of bipolar. Uh,
Right.
why people thought for a while that there was what they called kindling.
Hmm.
People who studied bipolar, the scientists, the researchers, and also the clinicians realized that bipolar tends to get dramatically worse year by year after onset. And so this
Right. And the
kindling,
more, I guess the argument for trying to lessen the frequency of episodes because it leads to a worsening of the illness. Like if you can minimize
that's
the number of episodes.
that was the theory is I think originated by the great Robert Post and the idea is like they came from the studies of epilepsy where they found
Right.
that animal studies they found that if they could artificially cause a seizure that then the tendency for seizure was far greater just because they had had the first seizure and they thought it was doing something incrementally that made it more likely. And so
Right.
there was a kindling theory of a number of diseases and eventually bipolar. And the idea was that if once you have a bipolar episode, then your brain has changed incrementally and it is like kindling. I guess kindling comes to the idea of starting a fire with
Right.
a
More
few
likely to
twigs.
happen with less.
But the episodes tend to make it worse and worse and worse and worse. I
Hmm.
think I've disproven that. I think it's clearly not that. What's really happening is
Hmm.
once you get the onset of the disorder, Well, you haven't fixed the oxidative assault, and you're continuing to get new and new mutated genes, and just because of the deterioration of your integrity of your DNA, it's going to continually get more and more complex and more mutations. And I think that is definitely the cause of the progressive worsening that everybody sees in bipolar.
Is it because of just natural aging, or does the episode itself, is that another insult on the
I think it's
DNA,
because
or
of
both?
the accelerated DNA damage, which we can prevent. See, that's the clinical arm
Hmm.
that we have. We probably can't do anything to fix the
The
ion channel
gene.
genes, and we probably
Right.
can't do anything, at least near term, to fix our genetic inability to accomplish good DNA repair or to regulate oxidative stress. But what we can do is we can eliminate this accelerated DNA damage. We can stop it in its tracks. If let's say in 10 or 20 years the genetics studies have been improved to the point where you could take a newborn child or a young child and do a complete genomic study of them.
And predict.
Eventually, I think this is going to happen, and people are going to be able to find out so much about what's happening with every gene and every gene team that they will
Mhm.
be able to identify people who are prone to bipolar disorder.
Right. And so that would
However,
mean antioxidant support or specific.
severe two factors, uh,
Mhm.
either excessive free radical assault that's not being
Mhm.
protected by our genetic protectors,
Right.
or genetic weakness in DNA repair. Could be either of or both of them.
But interventions or prevention would be, I guess, how to protect the DNA through
Yeah.
antioxidant support. And is this
Yes, and
different?
so now there's if you're looking at the most recent couple of years in
Hmm.
neuroscience and people studying bipolar, what are they finding? They're find they're finding damaged DNA
Right.
primarily in bipolar. And one of the most interesting things for me was to find out that they're finding superoxide free
Yeah.
radicals.
I was going to ask you that.
Superoxide, not we are over for the last 30, 40 years. I thought we were really great at antioxidant support, glutathione, catalase, zinc, and all the vitamins. We have all
Mhm.
these weapons that are wonderful at antioxidants. But 1963, somebody discovered the presence of superoxide. Well, what is superoxide? Well, superoxide are especially serious, quite different oxidative assaults,
Mhm.
and they aren't touched by glutathione and zinc and all these vitamins that we've been using. They are
Mhm.
impervious to that, and that's what the scientists are finding loaded up in the brains of bipolar patients, and I think also schizophrenia patients. So we have genetic protectors. There are three genes that have the job of regulating these superoxide radicals, and they're very weakened in some people. But
Mhm.
but that
Mhm.
that I it's it we have to we are now developing therapies. In fact, there are
Yeah.
supplements you can take. One of the three genes. One of them is copper, zinc, superoxide. Okay,
Mhm.
and another one is the number two is manganese superoxide. And the problem is that it's not so much the superoxide itself that can attack your DNA, but it reacts with other chemicals and forms hydroxyl ions, which are really vicious and are not touched by all of our normal antioxidants, and also the ONOO radical. And that's what they find in high levels in people suffering from bipolar.
Right.
So it's there are free radicals that are continually having the major assault on our brain. And now we know what the enemy is. And
Hmm.
so I don't think it's going to take too long to develop um, really targeted, advanced antioxidants that will fix that problem. So we're going to have the ability to stop it in its tracks. This slowly developing disease that takes 25 years typically before onset. I think it's sort of a
Hmm.
roadmap for prevention, all depending on how fast the genetic knowledge can, and it's advancing so fast. I think it's just a matter of a short time, maybe 10 or 15 years, when we'll be able to unlock all this important information buried, hidden inside our DNA and identify people's weaknesses. Wouldn't it be nice if on a newborn baby you find out, well, this little girl is prone to breast cancer, and know that,
Hmm.
and then find out how you can prevent it. I think that sort of thing is going to happen. And
So
and
even with bipolar disorder, sort of
well, with
targeted treatment,
bipolar,
even before the onset.
yes, and
Hmm.
you can stop it in its tracks, and maybe it will
Yeah,
never develop. So I think there's a
yeah,
roadmap for that. But the other thing is people who already have this nasty condition. It's a
exactly.
very complex condition. It gets more complex with age. Yes, if you can get early intervention, maybe in the first 5 or 10 years of the illness, you can probably prevent it from getting really terribly worse.
Hmm.
Myself and my colleagues, again, I've seen more than 1,500 cases and worked with doctors, and no doubt, if we get someone young who's just developed the condition, many of them become quite well.
Yeah.
And, and most of the patients we saw said that we helped them somewhat. But the really nasty thing was that didn't help that we weren't satisfied with the improvement. And if you look at we now have a lot of medications. There's $9 billion revenue for just the medications for bipolar in the US alone. And we have a lot of counseling and we have a lot of therapies and things
Hmm.
that do help somewhat. But um, but it's not enough. And the data on bipolar that's really shocking is the rate of suicide. And
Yeah.
there's some studies that show that nearly 50% of everyone who has a bipolar diagnosis will attempt suicide at
Hmm.
least once. So that's sort of the commentary
Yeah.
on on the inability to help these people, even with all of the medications and all the
Hmm.
caring, loving people trying to help them. Um, I so that I also think that another question is why do some people get bipolar one and why bipolar two, or why is it a
Hmm.
milder form with psychothymia? It looks to me like it has a lot to do with everything else in your brain. In other words, some people are prone to anxiety disorders, or
Right.
maybe they're prone to schizophrenia, or maybe they're prone to obsessive compulsive disorder. There are other
Hmm.
mental conditions that a person may or may not be prone to. And I think it's additive. I think that bipolar is a singular illness, and
Hmm.
however, it often, if you have someone who might have their DNA might be undermethylated at birth, and perhaps they're a natural tendency for very low serotonin activity, which means
Right.
probably unusually prone to depression. I think they're the ones who are more prone to bipolar 2. So I think it's additive.
Hmm.
I think so they have a more of a tendency for depression, whereas there are people who are born with a tendency for elevated, you might say, norepinephrine and dopamine, and maybe they have tendency for panic attacks and anxiety attacks. Well, they already have a tendency for hyperactivity of
Right.
these neurons, and I think you get an additive effect, and I think
So
that's one of the reasons you get different types of bipolar.
would you still find that most people with bipolar 1 are over-methylated, or does this research impact how you look at that?
No, interestingly, we've not seen that.
Okay.
I've checked over the data that I have, and not quite so much. But I think that there's a tendency in that direction. No one has actually done that study, and that would be a great study. And maybe I've
Mhm.
got enough data that we could really look at everything on that because we know their methylation capability. But there's more than just methylation.
Right, right.
Methylation has a tremendous impact on DNA. It affects virtually every gene. The presence or absence of a
Mm-hmm.
methyl molecule, or at the near near the gene itself, has a lot to do. And if it's methylated, it tends to shut down activity. The absence of it means that it's likely to fire more frequently. So we know all of that.
Okay.
But other things can go on. I mean, there's a lot of things
Okay.
a lot of other factors that could cause anxiety or depression that are unrelated to methylation. I mean, that's one of the major
Mm-hmm.
factors, but there's all these other things.
Okay. Okay.
And I've listed a lot of that. And it's a lot of complexity, but it can happen to anyone, regardless of their methylation status.
Do you want to comment briefly, and I know it's complex, but on the switching, and if you could just describe very simplistically what's happening when someone goes from a normal mood into a manic state, then into a depressive state from a neurotransmitter standpoint? Do you think that's too
It's all
complex?
interwoven. We used to think that our neurotransmitters were sort of functioning independently, and now we know that they are intimately related, and
Yeah.
that actually almost every neuron you've got, whether I'll say a dopamine neuron, it has receptors for almost every other neurotransmitter there. And
Yeah.
so they interact with each other, and they they anyway that complexity is there. But what we find with bipolar is that it can hit anybody, I think, regardless of their mental tendencies. And
Mhm.
what'll happen is that they will slowly and gradually have a tendency, a loss of regulation of neurotransmitters. And I don't know why, but it's clear that it tends toward hyperactivity of the major neurotransmitters. Okay.
And this is
And
because
and
of
it's
the
and
channelopathy, assuming because of that
it
channelopathy
well
or the genes that affect the channels. Is that?
Well, it happens to be a channelopathy. It happens to
Mhm.
be a channelopathy. Not all channelopathies are bipolar, but
Okay.
it
Okay.
is a channelopathy, meaning that it's really it's a ion channel disorder. But what happens is when I discovered that it happened to be ion channels, well, this gave me a real advantage. The next question is, why do people cycle? Why do we have this switching?
Right. Right.
And from all the data I had with all the patients we had seen, I learned that if you could succeed and correct the mania, they almost never became depressed. However,
Hmm.
if you had someone in the depression phase and you were fortunate enough to fix the depression, they always became manic again. And so my conclusion was it looks like mania is the cause of depression phase.
Depression.
And
Hmm.
so what could happen? Well, we know that mania tends to get worse with time after onset. So what's happening? And I looked at various ion channel abnormalities that could lead to, first of all, cause that. And could it be that one of these neurotransmitters, there's several of them that are being hyperactive in the beginning,
Hmm.
maybe one of them can actually be so damaged that it will stop functioning properly. So I looked at that possibility, and I found that there were two ion channel possibilities that could explain switching. But anyway, the one that's most common and looks like the right answer is that every time a neuron fires, you have potassium is lost, potassium ions are lost, and sodium ions rush into the neuron.
Hmm.
Now, it's a tiny amount, and 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 um, and the regulation of neuron functioning is so terrific that it's amazing at how quickly the neuron recovers to the proper ion distribution across the memory so quickly. But that gets damaged day after day after day after day.
Right.
And so it looks like we have potassium ion flooding outside neurons
Hmm.
gradually. And the neuroscience has a lot of explanations for how that might happen. But in a channelopathy, in the ion channels, there are many different ways in which ion channels can go wrong. But the net
Yeah.
result looks like it's flooding of, of potassium ions outside the neuron. So what does that mean? It means your threshold voltage, the voltage it takes for to
To fire.
get to the triggering point is shorter.
Hmm.
Shorter. Your resting potential is smaller if that happens. And
Hmm.
that's well known. And they know that if the level of the amount of potassium ions outside the neuron gets normality is around 3 micromillimeters. That's what's normal. And but if it gets to 5, those are people who are hyperactive. They tend to get
Right.
hyperactivity. Between
Right.
5 and 15, you can get things like epilepsy. You can also get
Hmm.
mania.
So what's
Mania
happening
is
at the
just
neuron is really
the
evidencing
neurons
something.
changing, yes, and are
Yeah.
becoming more and more hyperactive.
Right.
And then if you go even higher, there's data showing that you can get that as high as 80, and it's called cortical. There's a term for it. It has nothing to do with bipolar, but it shows that parts of the brain can shut down completely. And so
Mhm.
if one of the neurotransmitters is more vulnerable, and one of these hyperactive, uh, perhaps it would have a nonstop increased flooding, and when it got flooded to a certain degree, it would shut down. So I started
Mhm.
looking at neurotransmitters that, if they got sharply lower activity, are associated with depression. So I was left with 5 of them. So I evaluated serotonin, norepinephrine, dopamine, GABA, and glutamate. And this is chapter 10 of my book, but I spent a year looking at clues that could tell me which. I mean, I believe that one of these was so vulnerable and is actually shutting down, and that once it gets really impacted, it switches into depression. It can
Yeah.
dominate brain function. And
Hmm.
so I did that. And I had 5 criteria, which looking for clues to which one it was. And to my great surprise, it was serotonin,
Serotonin.
to
Yeah.
my surprise. And it's a surprise because in the last 20 years, the all the scientists and researchers have been saying that it looks like serotonin is not the major neurotransmitter involved.
Hmm.
It looks like it's dopamine or norepinephrine. That's where and with for very good reason. But I think I found out that it is serotonin. And so now, not only did we discover the cause of bipolar, or at least certainly the likely cause, I'm
Hmm.
95% sure. Of course, no one's ever
Yeah.
100% sure in science of anything, but it also gives an explanation for cycling. The beauty of the cycling thing is that if you have let's say the serotonin neurons shut down because they got too much flooding of the potassium ions, well, that would initiate depression. If you have
Right.
dramatically low serotonin activity, it could dominate brain function and cause depression. The beauty of this is that it automatically recovers. It
And puts them
automatically
back into a.
recovers. And the reason
Hmm.
it recovers, the activity is shut down, so you have greatly less potassium leaving the neuron, but you still have surviving clearance product. In other
Hmm.
words, there are systems in your brain that continually get rid of the excess
Yeah.
potassium. Well, they're still functioning while you've stopped flooding the outside of the neuron with potassium. So you would expect, it wouldn't be a surprise that the depression would go away. It would be expected.
Hmm.
And that's I
Any
think a
thoughts
beautiful
of
part of
why
it.
it would be longer for some people
Yes.
or the duration, how that might vary for
Yes.
people?
And I think it depends on the severity of the mania, because during
Oh,
mania often is months, many months long, and you get adaptations. For example, if you have a flood of a neurotransmitter in a synapse, the receptors become less and less effective. It's just the way the body
Hmm.
compensates.
Yeah.
And there are a number of these compensating factors that build up so that once you've managed to clear all the flooded potassium during the depression phase, that's why you don't immediately go back to mania because you have these
I see. Yeah.
compensated factors going on.
Right.
It's a little bit
Right.
complicated, but basically, um, then the question is why euthymia? Why is it that in most cases, after depression ends, you have this very welcome period where you don't really
Hmm.
have mania or depression. It may
Yeah.
not be functioning perfectly, but and for some people that can be rather brief, and for some people it can last for a year or more. And the question is, how do you explain that? And that's where things get a little bit more complicated. And it has to do with the fact that whereas norepinephrine and glutamate and dopamine are excitatory,
Dopamine?
serotonin is inhibitory. So if you get
Hmm.
serotonin activity on any of your neurons, it will
Hmm.
greatly tend to reduce activity. So anyway, so now what we have is we know that euthymia may not be the end of the depression phase. It might be the original phase at onset.
Mm-hmm.
Because if you're
Right.
getting the if you have the serotonin activity is accelerating and hyperactive, it tends to shut down dopamine, norepinephrine, and it looks like
Right.
the first stage of bipolar might, and I'd say this is
Hmm.
likely, but not proven. That might be what a euthymia is, and it's after the serotonin activity declines sharply that you get the beginning of true mania.
Right. So
But the
that
depression,
normal mood for people listening, yes, that normal, seemingly
yes,
normal mood could be actually the beginning of the.
and it's why the mania tends to get worse and worse and worse as the serotonin activity drops and drops and drops, and then eventually
Wow.
serotonin basically stops functioning. The
Oh,
potential
inhibitory effects.
is so
Yeah.
low that it doesn't form quality action potentials, and that would be depression.
Wow.
I
Okay.
think it all makes great
Yeah.
sense.
Yes. Wow.
Hopefully, it's correct.
How satisfying was that for you to have that all fit together? And
Every bit of it was a thrill. Finding out that it was a DNA damage disorder, and that was sort of the very beginning. That led to the proper analysis of the GWAS genetic data and
Mhm.
identified the cause being the ion channels. And then the next question is why, and that led directly to finding the cause of the switching. I had an unfair advantage. I feel almost bad about this. Everybody else has been trying to study the reason for switching. That's been going on for decades. And there's been
Hmm.
theory after theory, and still it was unknown at the time I began all this. It's not fair that I knew that it was ion channels. So I didn't have to look at these other 100 things that could be going wrong. Just focus on ion channels, and that's how I got there.
That's incredible.
And I thought, well, we're a not-for-profit, and we have learned something that might really help these people with this
Hmm.
horrible disorder. So we opted to quickly put out a book, get it out there, and we hope that word gets out that perhaps we have learned something really important about bipolar that could help patients to a degree even early. And so that's
Right, right.
and most people that write books like this are sold by Springer, and they usually charge two or three or $400 a book. Well,
Hmm.
we're not for profit, and our goal is not to make money on royalties and sell books. Our goal is to somehow see if this could help all these people with this
Right.
terrible disease. So it's $32, and which is reasonable, and
Hmm.
it's going to go on Kindle really quick, and it's going to be
Yeah.
and royalties might be insignificant, but we want the word to get out there. I think that any psychiatrist who has bipolar patients is troubled by their inability to help them as much as
Yeah.
they would like. We all have that. I've been part of that. And and if they happen to, if any of them happen to read my book, I think they're gonna suddenly realize that they have to give attention to the degree of oxidative assault.
Right, right.
And they have to think about, well, what can I do? Or what even doing our typical antioxidant work would actually fix two-thirds of the
Mhm.
oxidative assault.
So can you
And
comment briefly on so this requires um, a specific kind of antioxidant support beyond that.
well, you
And
can
I
do
know you don't lay
probably,
out treatment protocols, but just generally,
let's put it
um,
this way. The one of the big pro you have to also get hydrogen peroxide levels down, and that everybody has a lot, and that's what happens every time you have immune function
mhm,
and you have your mitochondria making energy. Your these natural processes are causing a lot of hydrogen peroxide, which would assault your DNA. And however, the antioxidants that we've been using are very good at that. But most bipolar patients have never had antioxidant therapy.
right,
So they,
right.
they would benefit greatly just by our standard garden variety,
Hmm.
excellent version of present day knowledge about antioxidants, vitamins,
Hmm.
and whatever you do to
Right.
increase glutathione, catalase, and all these others. So they can help them to a degree right now. It's just that about one-fourth of the assault we can't
Hmm.
quite touch yet. But we can help them a lot already
Yeah.
just by doing that.
Yeah.
I think that this could lead to better drugs. Now that
Hmm.
see drugs now are based on a diagnosis, and they'll do a study that
Right.
shows efficacy for a diagnosis, and the it would be far they can develop some drugs have really powerful antioxidant ability now. Some don't have any. I
Right.
think they can develop drugs that might really enhance protection of your DNA. And that would also help them to maybe get a better idea of what the disorder truly is. They might develop drugs that could be targeted at combating potassium flooding.
Hmm.
It might be a way for
Hmm.
them to quickly get dramatically more effective drugs.
Right. 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 And as you said, then ultimately prevention, which is incredible.
That's to me the real
Yeah.
exciting thing. I think it's so easy to prevent. We know how to prevent even now.
Hmm.
What we don't know is how to really make a person who has the disease as well as we would like.
Right.
We are not very good at. We do know how to keep it from getting worse, how
Hmm.
to stop it in its
Yeah.
tracks so it doesn't get worse year after year after year.
Right. Gosh,
And we got to
I
find out
could
which
talk to
one.
you all day.
Well, good talking to
This
you.
is, this
Enjoyed seeing
is
you again.
really so exciting. And I'm honored to be able to help share some of this information. The people that follow my podcast and newsletter have heard a lot about pyrroles, undermethylation, the NMDA receptor, copper overload. So
All of that.
this will really complement that. And I'm so grateful for your work, but also for your presence today. Really
Well,
appreciate
I had
it.
originally planned and hope my goal was to take 1,000 practitioners and educate and train them so they could learn to do this. Well, we're now working on our second 1,000,
That's
and
beautiful.
more than somewhere between 1 and 2 million patients have already used our protocols.
Yeah.
But we have I think close as I can tell 1,250 doctors like yourself that are now doing this. Just want to say that
Mhm.
you're probably one of the certainly, I had hoped that some of the people that we gave this information to would take over. I sort of feel like I'd like to be giving the baton to a bunch of people
Oh,
as I get older. And
glad to
I
be
think you're
part of that.
one of the 10 or 20 or 30 that is really going in that direction,
Oh,
besides
thank you.
trying to identify how you can help their patients, but maybe sort of leading the way in getting this
Sharing.
out. Getting
Yeah,
it.
I've been
So,
honored too.
so
It's
thank you
so
for doing that.
satisfying. It's so effective. And then to be able to get it out there is really satisfying. So thank you. Really appreciate
Well,
it. All
best of luck
right.
to you.
I'll look for an opportunity to talk with you again.
And we'll make sure you get a book soon.
Yeah,
Bye.
thank you. Bye-bye. Thank you for listening. If you'd like to learn more about the Walsh Research Institute and the work of Dr. Walsh, you can visit walshresearchinstitute.org. I'll also share links to my interview with Dr. Walsh, as well as a summary newsletter that I did on his discoveries in bipolar disorder, and my interview with him about his earlier discoveries and his journey into nutrient psychiatry. To receive these newsletters in your mailbox each week, please consider subscribing at CourtneySnyderMD.com, where I also have information about my non-patient phone consultations that I offer nationally and internationally, as well as my treatment practice. And I also have information about my mentoring groups, which I offer to physicians, nurse practitioners, and physician's assistants. Until next time, take care. Bye-bye.